Hey everyone, and welcome back. Up next, well, before we get to that, we've been having a ton of great talks about resiliency, about reliability, how to make things better. And I know you're learning a lot and you're all going to put this into action, but I want to guarantee you and reassure you that resiliency and reliability is in your future. And the way that I know that it's in your future is our next speaker is from the future. You see, our next speaker, Allan Shone, is from Australia, which means that my tomorrow is his today. So welcome to Failover Conf, Allan Shone.
Thank you, Jason. Hi, everyone.
And yes, it is
8:30 in the morning. Nice and sunny and warm outside in the sun. And yeah, I'm very excited to be a part of this conference. And what I'm going to talk about today is built-in application resiliency. For me, it's really a combination of, I guess, all parts of a stack, all the way from a physical hardware sitting in some data center up to some person consuming some sort of a service or application. So resiliency then, it comes down to a few things. The initial thought for me is around fault tolerance, handling sort of transient issues as they might happen, or glitches and that sort of thing. We find that a good way to showcase resiliency is to be consistent in the behavior. So we want to make sure that even when times are tough, we can keep plodding along as would be expected by consumers of whatever we're working on. We need to be able to recover from any sort of failure, whatever that might look like. It will heavily depend on whatever it is that's running at the time. And then to really understand that we are being resilient, we need to be comprehensively observable. So we need to be able to measure whatever's happening and keeping track of what our applications and services are actually doing at the time. But then we also need to plan for some sort of recovery, because massive disasters can and do happen, and they probably will happen at some point if they haven't already for you. And as always, the only constant really is change. So we need to adapt to pick up and keep going and just make sure that whatever comes our way, we keep meeting the expectations of what we're aiming to achieve. So I'll start off with recovering from disaster. And for me, this feels like a very natural place to begin, primarily because you can also use it to put together your foundation. So you start off with a solid baseline, and that gives you a really good spot to expand and build and keep going. It also means that when something disastrous and completely fails, you can go back to these basics to get up and running again with minimal effort, minimal time, minimal disruption. And that way you can keep getting back to the original purpose to achieve the outcomes that you're aiming to achieve. I think of this also as heavily using infrastructure as code, and that's for sort of all aspects of this, really. It's not just for recovering from the disaster, but it's also giving that solid plan, the foundation up front, that means that you can recover, or you can grow, you can change, you can adapt, and keep going just as what you need to do. It also means that you can take some time to really stop and think about all of your systems as a whole, which then informs the rest of what you're doing, whether that's being observable in a really comprehensive way, whether it's being able to adapt in a automated and nice way that's relevant for your service, or just being able to converse with even non-technical people across your business about individual aspects of the applications and services that you're running. It also means that everything's reproducible. So if you need to simulate a series of events, then you can go ahead and get to a point where those events have been triggered, and then you can run the same thing again and find out what happened, if it does happen, of course. Or it also means that you can see that perhaps there were transient issues that caused it to fail in the first place. The other positive aspect I like to call out with disaster recovery is planning from the point of recovering from disaster also means that you can prepare to scale really well. I'll talk a bit more about that later, but it's mostly around being able to either tweak numbers or duplicate pieces of your infrastructure to handle whatever you need to handle in a very quick fashion. Like, you don't need to go into a bunch of servers and start running commands to add more capacity somewhere. You can script it all to happen without much effort. A lot of this opens up the ability to move quickly, but it also comes down to the way that your applications and services run. So you can grow a lot quicker by having the ability to copy paste code and then bring up infrastructure, or you can just be better prepared. So when you bring new people into the team, because the team expands, there's a lot more responsibility, there's a lot you're looking after. Onboarding new members into the team can be a lot easier because you've got code there. You don't have to give them network diagrams that they need to go and poke through SSH to get to different places to work out what's going on. You can look at PRs to see changes that have been made, or you might see a PR that talks about, like, oh, we want to replace a service with something else, and so you can see the actual components that are required there. Or it might be something about fixing a bug of two services being able to access each other, and the PR just contains the security group differences. It also means that you have the ability to fully replicate your system as a whole. So you can have the full definition of your system set up in such a way that you can run it somewhere else, and you should get to a spot that means you now have two versions of the same thing running at the same time. And it also means that individual components can be tested and changed, and they can be tweaked smoothly. So you might decide that you wish to change your database provider, and all you need to do really is update the database definition itself inside of your infrastructure as code, and your application will presumably handle that very smoothly. So then in a disaster, we want to be resilient, and I guess the most blatant or heavy-handed way to do that is to start fresh. It might be a matter of, say, a region in AWS going offline. And if you were only running your infrastructure within that one region, that means you're now offline. So the best way to handle that from a recovery and resiliency perspective is to bring it up again. Now, if you handcrafted your system as a whole, that is going to be a very painful time for probably more than a couple of people. Whereas if you have your full infrastructure set up as code with Terraform or whatever you'd like, you can take that and pick a different region and then run it all. And it might take some time just because spinning up services takes time, but it will be a lot quicker than doing things by hand. So this also means that you can prepare with this plan to prevent as much loss as possible. So if you know that you need to make some changes and these might be breaking and catastrophic for your current services, then you can always use the plan to bring up fresh infrastructure so you can fail over if something does go wrong with your changes. This sort of thing has happened in the past, say changing the network configuration on an EC2 instance. We might feel that it's quite risky to make this change. So what we'll do is bring up a brand new instance based off of a snapshot, and we can kill the security groups so nothing actually happens there. But we then make the change, and if something does really, really break, we can switch all the configuration over to that brand new instance. So I feel having disaster sort of inform this sort of direction means that you could be really prepared to pick up and be resilient as things happen. A common place that failures come in and resiliency really needs to take over is during change windows. And this is usually a deployment of the application itself, but it's also a great way to facilitate resiliency in that sense. So if you have this type of massive disaster that you need to recover from and you need to recover quickly, then making deployments, if your deployments are quick, then you can get back up to speed a lot quicker. So if you have one monolith that takes 2 hours to deploy, that means you've got that deployment on top of your infrastructure build to actually be ready to recover from failure. But if you have something a bit smaller, or even the same sort of monolith, but your deployment takes 10 minutes, then that's only 10 minutes extra on top of the infrastructure deployment. That would be interruption time for your consumers. The next topic I wanted to talk about is fault tolerance, and that really comes down to just making sure that as things happen, you know, some solar flare comes along and shifts a bit somewhere you don't expect it to, and you can just pick up and keep running with it. So it's all about being graceful when there are issues. And the good thing about this is that there's a lot of patterns and a lot of libraries that help out with this. The most notable one are circuit breakers. And as mentioned as well before, there's things like kill switches and other types of setups that might be a lot more suitable depending on your application itself. And one of the concerns about being tolerant is around usage patterns. And by that, I mean the way that your services and applications are interacted with. So managing infrastructure as a service or a platform as a service will be different to managing, say, a media website, which is primarily user-driven in browsers versus server-to-server API calls. And these two setups, while there's a lot of similarity, of course, they all respond to HTTP calls, but the patterns by which these interactions happen will mean that tolerance is a different concept. So you can still use the same patterns, but you might change the numbers, or like your timeouts might shift depending on the use case. And really then it comes down to meeting the expectations of the consumers. So if the expectation is that an error is going to respond with an appropriate HTTP code, then that shouldn't change over time, and the consistency really becomes important. A good way to help with this is around like non-direct or indirect application pieces. So, for instance, you can use a service mesh to handle a lot of these things for you. In a mesh, you can set up the circuit breaking itself to better, I guess, handle when your service is struggling with something, and that way you don't need to change your service. It's especially helpful when you can't change the service that's running. You can also do this at the load balancer level. You might round robin or some other way of distributing load between services or servers. And so as one server might start to fall over, your load balancer will go ahead and send traffic to a different server until either the slower one recovers or becomes unhealthy and is removed from the load balancer entirely. This is also another case of DNS, which may or may not work for anyone, really. But you can do a similar type of thing, especially around percentage-based routing. So you might set up a small percent for a canary deployment at the DNS level to go to a different piece of infrastructure. And that way you can see how things are going and make sure everything's working as expected. Another good way to do a bit more on the resiliency front from within the application itself comes down to, I guess, thinking smart about the way that your application executes what it needs to do. A good way for this is then to have an internal library so you can standardize on the way that these approaches are done and share all of the hard work without people reinventing the wheel each time. You can set the right defaults then. So you might have internal SLAs and SLOs that would give you like a shared default on responsiveness internally. And so you can enforce those with a library. It also means that you can define expectations for individual components. So you know that certain components might require extra time. Maybe they need to handle a file upload and then execute a virus scan. And that's usually going to take more than an insignificant amount of time. So on that particular service call, you would allow for a longer time period. And I guess the trick there is to handle or make sure the edge cases don't become the norm. So you want to keep as much standardized function as possible without trying to cater for absolutely everything. It's a good place for other patterns as well, like an exponential backoff. So you might have all API calls use the same HTTP library, and internally that library will automatically follow the exponential backoff pattern. So as it fails, it'll retry, but if the retry fails, it will wait longer before trying again until eventually failing entirely. The next concept is around recovering from failure then. And as it seems to be a very common thing, failure happens, and it's always going to happen. The best thing to do is to set expectations on what failure looks like and how you handle that failure. The benefit of thinking about this within an application itself is that you have control over it, and you can then best take care of whatever it is that you need to take care of. I like to use buffers and caches for this sort of purpose, whether it's some sort of a queue or you have a library or a tool that uses a Redis or another fast sort of caching database where you can put, say, messages to be consumed later. For instance, if a downstream service is failing, you might store a message to then push data to that service later on as the downstream service recovers. And that way you can be graceful with the way that you degrade your service for the user-based expectations. Because really it comes down to managing that expectation. Your user makes a request and they expect some sort of a response, and you want to be able to give that to them quickly. And it's okay if you say, cool, you know, we've taken this, we've put it into a buffer, it hasn't completed yet, but we haven't lost it and it will make it there eventually. So buffering then, great example, as everyone has probably found, is in video. And that's especially the case when you're on a flaky connection or a slow connection, such as living in Australia. Buffering is a very common occurrence. And it's just about having that expectation met. Your user might expect that a video is just going to stream at 4K on their dial-up connection, but it's not going to work that way. So managing that expectation becomes really important. And then for these buffers, it's a really good idea to validate them. I've been a part of incidents before where this sort of a setup was used to handle the capturing of messages to a downstream provider that was having API difficulties, but we didn't have the appropriate monitoring in place and our internal buffer filled up, and that then caused our application to have an outage. So it's a tricky one to get right. And sometimes then it might come down to better long-term solutions, especially in the case of services that fail often. You might need to have a better way to work with them. But I guess the easiest way to be really resilient from a user perspective is to push the heavy lifting to an out-of-band process, which might be this queue consumer, but you can manage the way that you do this perhaps by using a longer-term storage if there are proper long-term problems. So for the out-of-band, you can catch up a lot quicker, so you can get back to a proper state of normality. You can always throw more compute at pushing through a queue, which of course might then cause further outages downstream, but that's something that you can manage on each individual scenario. But it might become a good part of your architecture to use this buffer all the time. It might be more suitable to keep that then as a part of your application and always push things out of band rather than only when there's downstream problems. So you may end up changing your architecture. It does bring to mind a concern around duplicating efforts and duplicating business logic, but that's just something to be mindful of. So then behaving consistently, I think is a pretty big concern. And for me, it really becomes a core part of reliability. And because really when I think of reliability, I think of something being reliable, and generally that just means being consistent. And so consistency, resiliency is born out of the ability to keep this consistent behavior as circumstances change. So as load increases, your website still works for your users, or your API continues to consume messages and take actions. It might slow down, it might delay some things, but it will always respond the same way for the same requests. And the buffer then becomes really important in being able to keep this consistency, especially under massive load and larger scale operations. It's also important to think about adapting. A good way to keep resilient and be consistent is to adapt. And for me, adapting in this context it comes down to, I guess, augmenting behavior rather than modifying it, because if you modify it, then you're probably going to break the consistency. And so we want to keep consistent, so we need to augment rather than modify. And finally, the biggest part overall then becomes being observable, because how do you know if you're resilient if you don't know what's happening? So you need to have that visibility, and that way you can really prove that you can be resilient and that things are behaving as expected, and you can then quantifiably show that you're meeting the goals and all the service levels that you've put together. It's important then from the visibility side to gather the right data, but it's good because you can come up with your own baselines, which then inform the expectations of the consumers of all of the components that you're managing. And that way you get that sort of general understanding of the reliability of everything. And from the baseline, one of my favorite things is the idea of having a feedback loop where your visibility informs the reliability, and the measurements then mean that you can have your systems adapt and pick up and run to be more efficient, or just to make sure that you handle whatever's happening across your platform. You might find that a queue is filling up, and so you need to add in more compute to work through that queue quicker. Or you might find that your utilization is dropping across your compute instances, so you can get rid of a couple of those to not waste resources. But with the data, you can have systems automatically adapt as they need to. It means that things can be really intelligent with the way that they happen, especially when your system's visibility is tailored to the way that your system works. You know that when certain things happen in certain circumstances, by making certain tweaks, you don't need to worry at all. And it also means that operationally, your employees are much happier because they no longer need to wake up at 2 a.m. Your system just adapts. So resiliency then is kind of this general overall thing. And for me, as I was sort of putting all this together, I realized it's heavily about managing expectations, and it's about having this service that you're providing, and there's some sort of expectation on how it works and when it works and how it can be used. And you then need to be able to make sure that you can meet those expectations, and if not, find a way to be able to work through challenging and updating those expectations to be more suitable for what you're doing. It's about being graceful, about being able to be comfortable with the changes that happen, and just carrying through as smooth as possible, and about being able to move quickly. So picking up, running, and making changes without or with minimal disruption. Adapting whenever things happen, so making sure to be able to handle the changes without troubles. That's it. Thank you.